pull it out away from you, it's kind of like the blue planet. You know, the Earth has been called the blue planet. And from space, within our solar system, you can see the Earth and the blueness of the oceans defining our planet. Okay, so that's the far view. If you bring it closer to yourself and you imagine that's a drop of water, there are some tens of millions of organisms and hundreds of, if not thousands of species of organisms living within that one drop of water, right? It's a remarkable medium for life. So let's begin. So what is it about water that makes it so interesting? Well, first of all, we know that water is a covalently bound substance. You learn that in physical chemistry. Has a really important dimension associated with the hydrogen atoms in the water molecule of 104.5 degrees. That is important because it gives water some of its distinguishing characteristics. It allows it to hydrogen bond with other water molecules. So what's being shown in the second figure off to the right upper portion of the slide is oxygen binding to other oxygen molecules, all right? And that's maximal when water is a solid, ice, when we're talking about ice. The other thing that happens because of the water molecule is that it's a polar molecule. That means that there's a partial positive charge at one end and a partial negative charge at another end. And that makes water a very important solvent for pulling apart, especially ionically bound compounds, right? And that's kind of what's being shown in the lower figure, with water easily pulling apart the sodium and chloride ions associated with salt. Now, one of the really important characteristics of water is it's one of the only substances on the planet that occurs in 3 different physical states. And this is probably really important for its ability to support life. We firmly believe that we will not be able to find life anywhere else in the universe unless we find water, at least in the liquid state, in that location. So the 3 states of water is unique compared to other compounds. Also, water is a remarkable solvent. There are some 65 to 70 elements that can be found dissolved in water. There's probably others that we will be able to detect in the future when we get better instrumentation, but it is able to dissolve all kinds of substances, especially ionically bounded substances. And this is certainly part of its magic, right? Part of the reason that it's so good and likely to be where we look for life if we're looking in other astronomical bodies. Also, it's good for detecting dinosaurs creeping up upon you, all right? So you have to keep that in mind too. A little drier is the density temperature anomaly. I hate to use that word anomaly, but it is a scientific term. And the anomaly is that, most other substances, as they get colder, get denser and denser, right? But that only happens with water up to a certain temperature, or I should say down to a certain temperature. At 4 degrees C, if we continue to get the water colder, it becomes less dense. And it gets even less dense than that when it freezes. And that's why frozen water forms on the top of water bodies instead of on the bottom, and that's why organisms that live in an aquatic environment, especially a shallow one, don't get encased in ice, because they get protected from that further temperature change. Now, we know that water exhibits this phenomenon called surface tension. Those of you who are in middle school have probably done this in your homes. You overfill the water glass and it's perfect. It's still bubbling up there, but it's well above the lip of the glass that you're keeping it in, and then you move it just a little bit too much and it falls over the side. But for a while it was pumped up there on top of the lip of the glass, forming this convex surface. That's from the hydrogen bonding of the neighboring water molecules, right? That same process provides the characteristics of capillarity. If you contain water in a small container, it will literally suck up along the side walls of the container, and that's what's being shown in that lower figure.